Good morning once again to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to learn how to deal with quadratic inequalities. Remember that inequality is not or should not give us a specific answer or a specific value of the unknown x. It should give us a range, within which range is x valid. That is inequality. But before we can go there, it is important to read this note that squares and square roots involving inequalities need care. And in example 15, Algebra 7, which says x squared minus 4 is less than 0. I want to outline the points that we need to follow. First of all, this one is a region, but that region has a boundary, and that boundary is a line. So know how to construct the graph of y is equals to x squared minus 4. This is the graph that is going to give us the boundary between the two regions. After we learn how to, before we can do anything, it is important to note that this graph is likely to have two types of intercepts. One, it is likely to have the x-axis intercept. And what I mean by the x-axis intercept is that if you can just have a small graph here, this is xy, this is the x-axis, this is the y-axis. Where the graph cuts the x-axis, that is called the x-axis intercept. And we all remember that this happens when the value of y is equals to 0. Because along the x-axis, y is always equals to 0. We are also likely to have another intercept, which could be called, this is x-axis, and we are calling those ones x-intercept. This is called the y-axis. We are likely to have the y-axis intercept, probably somewhere like there. And you can see, for us to land to this particular point, the value of x should always be 0. Because anything to do with x along the y-axis, it is always 0. X is always 0. So let us first of all talk about the x-intercept. The x-axis intercept, we have heard that y is equals to 0. Let's talk about the x-axis intercept. And for this to be realistic, x squared minus 4 is 0, because that is the value of y. In this, it means that x squared is equals to 4. And x must be, having found the square root on both sides, plus or minus 2. So at one point, x is going negative 2. X will be negative 2. And at another point, x is going to be a positive 2. Having said that, let us now talk about the y-intercept. And the y-intercept is when x is equals to 0. And you can see when x, y-axis intercept is when x is equals to 0. Then we have y is equals to 0 minus 4. So y is negative 4. Having realized that, now we can go ahead and highlight our points. We can highlight our point in the x-axis, in the Cartesian plane, in the x-axis Cartesian plane. Let us improvise this ruler, our ruler, and use this one as, so we have that one as the y-axis. We can have that one as the x-axis. There we go. We have seen that the x-axis intercept is minus 2, positive 2. Those 2 points, at least our graph must pass there. We have also understood that the y-intercept is minus 4. So our graph is also going to pass there. It could be the turning point. But before we can actually do that, let us see how do we get the rest of the points of the graph. And listen to this. Having realized that the y-axis intercept is negative 2 and positive 2, it is so much advisable to get values of x to the left of negative 2 and to get values of x to the right of positive 2, so that we can see how the graph is behaving below negative 2 and above negative 2, so that we can have then to understand the shape of the graph. This one is easy. To get the values, we just have to tabulate. And we can see the values of x and the value of y. We have seen that x is going to be negative 3, one value below negative 2. And negative 3 squared is 9. 9 minus 4 is 5. Then minus 2. Y is 0, as you can see, but you can also substitute here. Minus 2 squared, which is 4. 4 minus 4, 0. Let us see minus 1. Minus 1 squared is 1. 1 minus 4 is minus 3. 0. When x is 0, you can say it's here, which is y is negative 4. When x is 1, let us see how it behaves. 1 squared minus 4 becomes minus 3. When x is 2, again, you can see 0. And when x is 3, one step beyond the upper value of x. So 9 minus 4 is 5. So let us kind of plot this graph. When x is minus 3, y is 5. Let's put it there. Probably this is 5. When x is minus 2, y is 0. When x is minus 1, y is minus 3. Or minus 3, probably there, somewhere there. When x is 1, y is a 3. When x is 2, y is 0. When x is 3, y is 5. So we are having to join all these steps in a very, very straight line. Remember, this is the turning point, and the graph looks like that. That is our graph. And how do we name this graph? The name of the graph is y is equals to x squared minus 4, because that is the equation that gives us that line. But now the question is not solved. The question is not solved. We have not answered the question. The question is asking us, solve x squared minus 4 is less than 0. X squared minus 4 is always less than 0. It is now our duty to show that if this is the boundary, we need the values of y which are less than 0, such that beyond this particular line, that is the boundary between negatives and positives. These are negatives and these are positives. Now, we need to get a region whereby our values of x are negatives. So you can see that. So we are having, this is the unwanted region. This region is unwanted. This is the unwanted region because it is above. It is above 0. This is the wanted region. And for this particular question to make sense, we need to identify within which values of x is the statement valid. You can see this one is a continuous graph, and the boundary here is -2, and the boundary here is +2, and x have to be within those values. X has to be greater than -2 and less than +2. That is our answer to that particular question. Should this have been less than or equals to, then we should have brought the same here, but it is just less than, which is our final submission. Thank you.